Now we will go for dynamic analysis. Okay, so here I forgot to tell you how to copy these value from dead load cases to seismic load, so that will be more easy. Just go to editor file. Okay, go to editor file, select your loads where you have applied the loads. Okay, you click this and copy all the loads from member load. Okay, below dead load. Okay, just copy it and copy also this one. Just copy all the member load and also the live load. So I've copied ctrl-c, go to that position where you define the seismic. So below zone. Okay, see, I can switch off this from here. Okay, if you comment it, then it will be off and it is gone from this value. It will not applied on your software. Okay, if you just select it and comment it. If you want to again reapply in your building, then select all and uncomment it. Okay, so what we have copied, we have to paste here. We have So what we have to change the member load name as member weight. Okay, because in seismic weight is calculated, not the load. Okay, and we have to change that minus sign and the direction. You don't have to apply anything. So self weight, the sign and the direction has gone. For y range also, so it was not a floor load, it was a floor weight. Okay, you have to match the synonyms according to the softwares. Okay, so it was weight and gy direction has gone, no direction will be there. Okay, this floor load, this option has gone. So here will be this option value is also gone because we only need the value, and -2 has gone, and we have to also delete and put it 9 because on terrace floor it is not applied, so we have decreased the height. Okay, so let's see this. We'll save it and I hope that everything will be okay. Yes, okay, we will go and check it. See, okay, -15 we haven't corrected that, that's why it value is not changed. Now it's changed. Uniform load, or okay, distance was there but we have to go for weight, change, close 8, that was correct. Self weight is applied and the floor weight is also. So you can go to loads and okay, seismic load was, member load is applied, floor load, the maximum and the minimum value. So just give it. Okay, it is already given here. Okay, so it is also applied. Floor load already applied and these values see automatically applied. You don't have to again assign this value here. Just copy from there and just paste as how I am done. Okay, how I did here. So this value has been deleted from there. Okay, so best thing, if you want to delete, don't delete it, just comment it. So if you want to use it again, then you can select again and uncomment it, then you will use it again in software. Okay, so then now we have to also go for dynamic analysis, why I have already told you in earlier class. Okay, so the best way to go for dynamic is to use the reference load method, so where you can define the mass. Okay, see, I'm only going with the best option that I use generally. So there will be more methods to apply the loads. So yeah, if you want me to upload that also, I already upload in Hindi version, but if you want me to upload in English, then I will also do that. Just comment. Okay, so I will add the mass reference, and in mass what you have to do is just do the same thing. So here what you have to do, go for all the loads have been also applied in that, but see what you have to do, I will tell you. Define reference load. Okay, this one is the mass. Okay, here I am define the mass. Okay, so here what you have to also copy all the stuff, but you have to apply in all three direction. That is, if it is applied in gy direction, okay, so minus sign will be ignored, but it is applied in all three direction. How I will show you how it is applied. So member load, copy, again v, again v. So it is applied in gx direction, it is applied in gy, and it is applied in gz direction. Okay, so here you have to do the same thing for another load. Just copy all the loads, c and ctrlv, and again ctrlv for all the three direction. So minus is removed from everywhere because seismic load is used to calculate the weight, not the load on the beam. Okay, so gx, all three direction we are using. Okay, so that's why we are giving this value. Okay, that was correct, gy and gz. That's why it is called a dynamic analysis. Okay, it was calculating from all three directions. So ignore the self weight, and we have to provide the, oh, we ignore, I mean to say ignore the negative sign of self weight. Okay, don't think that I'm going to remove that self weight. So it is applied in x, y and z direction. Okay, similarly for floor load, just remove the sign and gx and copy the floor load ctrlc and v and v. So here it is coming gy and it is coming gz. Okay, and for live load also, so remove the live load option because we are only providing the loads. So gx, so copy is this, also ignore the top floor. Okay, from seismic top floor terrace load will be ignored. Okay, and ctrlz, gx, gy and gz. Okay, we will close this end of reference load. See, so we will close this. Here you will go to reference load, mass. See, so every load is applied from every direction. Okay, you don't have to do anything. Okay, and it is also applied to the building. If you manually come and type one by one, then you have to also apply to that structure. That will take much more time. Okay, see, from all three direction it is applied. Okay, so here you don't have to add these value. You can go and again what I have told you to just comment. uh, so below zone, select all, before reference, okay, and comment it and close it, okay. So you can check this from here that every value is removed, okay. And you can also go from load case and detail, and again go to seismic, just take it as R as X, okay. Add and seismic RXZ, okay, close. So go into RSX, again add it, and go to response spectra because we are taking the method response spectra, okay. Select the code in which you are working, so I'm going to IS1893, taking the SRSS method. So again go to RSX, select the RSX, go to add option, spectra, select your code, select the method, okay. Software will automatically tell you which method is best for your plan, okay. So I'm taking the CSM method right now. So because if you know the grade of your class soil, so you can also, you have to also select this medium type, soft or hard. So I'm taking it as a medium. Always use the damping as 5%. Just if you applied in X direction, go for this one and put the value. So this value is calculated from the formula Z by 2 multiplied by I by R. So Z is, you can go from here, okay. So Z value you have taken 0.075. So calculate your Z value from here, Z by 2 into I by R. Z is the zone, okay. So 0.16 divided by 2 and multiply by I, what is our importance factor, that is 1, and I is the response reduction spectrum reduction factor. So my welding was, I have taken a special moment resistance, so 5, okay. So value will be coming 0.016. Again go to that option, response spectra, code, CSM, and select the X1 to 0.016. Okay, if you are also applying the torsion, then you can select this value and apply to in both direction if you want to, that is positive and negative. And if you are applying in positive direction, then use this value as positive, and negative then use this value as negative. Right now I'm not using the torsion value, okay. Just add this. So put the scale factor 1, okay. And also the, so add this value, close it, okay. And RZ, so it was also calculated in Z direction. Do the same procedure in Z direction, 0.016, okay. Put the value as 1. Just you have to change this direction values, okay. Don't use the torsion right now. Add and close. So this value has been added here. Go to analyze and run analyze and just check our model was okay or not. One error was coming. Let's check out the error. No loading defined for UBC load. Okay, here it was showing that there is no load defined for seismic. So why it is coming? Okay, so we have to define the reference load before the seismic load. Then only software is going to take it. Okay, otherwise the sequence was wrong. So we could go for reference load, cut it, and just paste it above that. Okay, B. So again go and run analyze. See, error has gone. Warning is coming. Just go and check what warning is showing. So math model will be used in this. Okay, math model I already applied. So software was saying what he is going to do. Floor weight, ignore that. Mass defined under load kit 5 will be analyzed. So fourth and fifth load we have defined as RSX and SY. So that was software is showing us. Okay, so we can go to result. Okay, this eigenvalue response spectrum for a different for peak storage here. Every value is coming right now here. Model base action. Okay, so here mode participation factor. So this value you have to see the this value will be reaches to 90% as code has already told us how to do it. So if it was not achieved to 90% in 6 more, so we could increase the number of modes. Okay, so for x direction it is also showing the same, so we could increase the mode. Okay, px parameter in method. Okay, px. You can use the combination also. Okay, or one thing you have also to do in this, assign the diaphragm to all the floors. So it will help you to calculate the CG of the floor. Okay, so from where you can go and calculate that, I will show you. Go to specs, go to node point. So flow diagram, use this option. Okay, there are two options. You can assign this also, but here you should provide by yourself the master node, and here the software will automatically detect the master node. Okay, so this will be more accurate. So go for different flow for different diaphragm. Okay, just I am tapping it. Provide the height as what height we have given to 0. Oh, that was okay. Height of the floor, this height of the floor, so this was 0 at 0 height, so I am given a 0. Calculate, select nodes. Okay, add, go for second one, for second floor. Height was 3 meter. I'm taking is this as 3, so select node option, calculate it by software only. So for third floor 6, add, okay, change, and for fourth floor 9, and select nodes and add close. Okay, highlight assigned. So see, this value has been assigned. Okay, because I have already provided the height. Okay, see, on every floor every diaphragm is assigned. You have to select the node. Okay, to assign the diaphragm. So node is assigned. You can go to analyze and define command. You can check it from here also. And pre-print define command. Okay, every value will be okay from here, and go to mode shape, add, go for CG, add, go for drift also. Okay, let's check this value will analyze result. Will software give or not? Okay, so go and run analyze. So error was nothing, and mass model okay, mass model okay, no problem. Story drift will not be okay, no problem. Here story drift was not showing, but I will show you in the new version. You can, there the story drift will also be shown to you, that in connect edition. Okay, let's see, this is the flow diaphragm option also coming. So what we had applied always showing in this option. So rigid diaphragm is applied to every floor level. So floor weight has been calculated and center of mass of every floor will be calculated. Okay, this is a joint number. Okay, so these are the dynamic weight of in every direction. Okay, oh, it is plus 0.3 means 10 to the power 3. Okay, so these are the peak storage here coming at every floor in kilonewton. This value in kilonewton. These are the reactions that was coming. Okay, these are the participation factor. It should come to 90%. We have to increase the mode, I already told you. Okay, so for both direction everything was coming. Okay, so here story drift checking during response battle. It was checking according to response spectrum analyze load case. So these are the story drift values that was coming right now. Okay, so it was not calculated here correctly. Okay, we should check in another connect edition. Okay, why it was not calculating, but another this value for the main value, that is response participation factor and the flow diaphragm CG value, that was we are already seen here. Okay, so to increase the mode shape, what you should go to command option. Okay, miscellaneous, and here you are seeing the cutoff mode shape. So you here it is written 6, so you can increase it up to 9. Okay, and then okay, let's go and again analyze it and check whether it is increased or not. So we have to increase the mode to just go to 90%. Okay, go to output file, so directly go to the result. See, still it was not reached up to 90%. It will again increase that. Okay, so we are going to again increase the value. So here we have increased this value up to 90 12 mode shapes. So 99% was coming. So we can only apply to 10 mode shape. There also 90% will be achieved. Okay, so from this you can increase the mode shape to just go up to 90%. Okay, so in next lecture we will see how to analyze the and check the steel that was coming in beam and columns. Okay, so here error was coming as you are saying that px, the warning is there. So PX comparison of base share with the from that of fundamental time period node. So this value will be calculated from the software by itself, but right now it was somehow not calculating by itself. So so we should also give the value manually if you want to. Okay, that that may be because of error that was occurred during the classes. It was not calculating. So what should we do? These PX and PZ. So these value software is saying it was not calculated. So we can manually provide these values if you want to. Where if you go to ISCODE 1893-2016. So this is the fundamental time period. Okay, for different buildings. These formulas for without any machinery infills. These formula is used with the structural walls, RCC structure walls, and for another building, other building we use this formula. So we are going to adopt this one, that is 0.09 h upon root d. What is h? H is the height of the building. Okay, and what is d? D is the base dimension of building along x and along y direction. That is along the direction where earthquake was considered. Okay, so we are going to adopt this. So 0.09. So we are taking at 0.09 h is the height of the building. So take it as 12 and divide it by zero point 0.7. Sorry, root d. So root d is the base dimension. So what is the base dimension of building in x direction? If we are considering in for x direction, then we will see the dimension in, okay, is in x direction. So 5 meters. Okay, so 5, take it the 5 value. So value is coming 0.48. So 0.48, and for z direction, for z direction it is 8. So value is coming 0.17. Okay, so give this at 0.17. Okay, why this value is less and this value is more? Because the dimension in x direction is less and the dimension in y direction, z direction is more. That's why. Okay, so we have created these values also. See, here it is added. Just now go and again reanalyze it. See, these values will be automatically calculated when we only applied for static analysis. Okay, but somehow this value is not coming right now, so we can manually put by this formula. So I already shown this formula. Okay, from ISCODE. So these are fundamental time period formula. You can go and check from there. 7.6.2 clause. So see, still software was showing this value is missing. So it is some types of error because we have already inserted the value. Okay, so diaphragm is given here and all the value, peak shear, peak value, participation factor. See, we have increased up to 12, so it was 99%, but we can decrease up to 10. It was achieved as 99% here only. Okay, model based reaction, or just go and here to just again load data. Let's check it again once more. Maybe it was a software glitch because every procedure was correct. I already applied in my Hindi tutorials that I have been uploaded already. Okay, let's check one more time. Every value was okay. That was not any issue. So, so method was adapted. Different method is being used. So it was. Let's. Okay, not a problem. So we have checked it how to apply dynamic analysis. Okay, you can also do as same as I have done. You can get the result. Okay, so in next lecture we will see how to design the model. Thank you.